Greetings. This will be starting in specifically on oceanography. In particular, we'll be looking at a bit of the history of oceanography, how people have interacted with the oceans over time, things like that. And from there, we'll look at features of the ocean come next. So let's get the PowerPoint up here. There we go. As an initial introduction, I want to show a video here of an oceanographer talking about work and its importance, what it's like being in oceanography.
Folks ask, why should I care about the ocean? I'm not anywhere near it. It doesn't affect me. Science is showing us that most of the oxygen that we breathe comes from the ocean. The funding crisis for ocean science is really, really dangerous. That is going to affect all of us.
How long is that bird dog? 3/4 of a mile long.
Some people call me Deep Sea Dawn. I got interested in oceanography as a child, and then at the age of 8, I decided I want to be an ocean geologist. I've been on many, many ocean expeditions. I've been to parts of the world underwater that very few people have seen before. I have explored places and seen places for the first time, from Antarctica to the volcanoes under the Sea of Japan. It's been great. I'm still a child inside. What I love most about the ocean is the sense of adventure and freedom. To me, the ocean is life. Growing up in Hawaii, you are part of the ocean. The ocean is sacred. We are so enamored with how much we know about the moon. We know all about the different craters of the moon. We know about Mars and Venus, but we don't have the same level of understanding of the Earth. And that's because we have not mapped the oceans at the same level of detail. I'm the chief scientist of ESRI, which also stands for the Environmental Systems Research Institute. ESRI needs a chief scientist because science underpins everything that the company produces. ESRI creates a whole series of base maps, and one of our really important base maps is an ocean base map. It shows you the world's underwater topography. To have a map, a detailed map of the entire ocean floor is so important because it helps us to understand the totality of this planet. The oceans are doing this amazing job of absorbing the excess greenhouse gases that human activity is putting into the atmosphere. They're absorbing a lot of heat. The higher sea surface temperatures create larger storms, maybe more frequent storms. The oceans are really the engine of climate change, so we need to understand the oceans and to map the oceans for all of those reasons. By doing that, we've actually seen that when funding for science is cut, the consequences are severe. If we don't have the funding for students, we could lose a whole generation of creative, innovative scientists to help us push forward, helping to make these discoveries with us that make all of our lives better. With the recent cuts that we've experienced, I won't say that it's completely destroying ocean science, but it's certainly making it more difficult for us to move forward. our great ships of science, such as the Sally Ride and the Roger Rebel, sit in port, and everyone loses. In science, we're all trying to make a contribution. We all stand on the shoulders of those who went before us. So I'm just one of the pieces in the puzzle. If we don't make science a priority in this country the way that we have in the past, the stakes are that we will lose us. We will not be the United States of America that we have been. We will not be leaders and innovators. We will not be a force for good in the world. Science is intrinsic to who we are, to what we have become, the good things about this nation. We can't afford to go back.
Looking at the history of human interaction with the ocean goes back very long ways. Some of the earliest fossil remains that we have of anatomically modern humans, which means their bones look like ours, that's all we got of them, they are from coastal areas. And there are seashell beads associated with some of these remains, some of the very first evidence of people having art, culture types of things developed. Being near the ocean, it's relatively easy to get a fair amount of seafood, and that's a very handy source of protein. Humans with our big brains need quite a lot of protein in our diet, and so fishing has long been very important to humans in that way. We also see some significant travel across the water. Humans reach places such as Australia quite early on, crossing as much, at least, of hundreds of miles of water away from land. Gradually, we see more extensive exploration of the oceans by humans. The first phase is largely discovery, exploring. A lot of this is either looking for a new place to live or searching for more ocean resources, fishing and other things as well. Over time, we see more travel, longer distances, people develop better technology and knowledge for navigation, shipbuilding, things of that sort. Some examples. The earliest significant ocean explorers that we have documentation of are the Phoenicians. Although the Phoenicians did have writing, they were largely focused on trade and rather than reporting on what they found. So our accounts actually come largely from classic Greek sources. The homeland area of the Phoenicians was on the east end of the Mediterranean, in the area of Tyre and Sidon, just to the northwest of the area for ancient Israel. Some relationships between the Phoenicians and Israel were good. You had Hiram, who worked with King David and Solomon. On the other hand, some of the relationships weren't so good theologically at any rate. Jezebel was a Phoenician princess, for example. But at any rate, the Phoenicians were famous for their trade, and in particular, their most popular product, which they were able to sell for high prices, was what's generally referred to as purple cloth. Now, exactly what the ancients thought of for different colors, not necessarily entirely the same as what we do, but being able to color something a relatively bright and deep color was not something generally available. It was not all that common really until the 1800s with the development of artificial dyes. But various people around the world had discovered that certain types of snails, when disturbed, would secrete a chemical that, after some exposure to sunlight, would turn a rich purple color. This is actually basically the same color that is what is used for blue jeans and things like that today, so it can range from more purplish to bluish in the actual color depending on how you dye it. In Japan, people figured out that if you pick up the snail and poke it, it squirts out the chemical as a deterrent, and you catch that in the bucket and you can dye things and put the snail back in the rock. But the Phoenicians took the approach of gathering all the snails they could and smashing them up, and then using that extract in order to dye the cloth that they sold. Do that enough and you start to run low on snails. So the Phoenicians proceeded to spread with colonies around the Mediterranean region. For example, Carthage was a prominent Phoenician colony in North Africa. Eventually became a rival to Rome. And at one point, the Phoenicians actually had an expedition that made it all the way around Africa. Ironically, we have account of this reported in some of the Greek histories with skepticism because of some of the odd things the Phoenicians reported, which we now know would be true. And so that supports the idea that they really did make it all the way around Africa. Certainly they traveled widely in the Mediterranean on out into the Atlantic, along near North Africa and Western Europe, and also through the Red Sea on towards the Indian Ocean region. Pytheas is one of the first travelers, along with Herodotus, that we have a specific name. Both of them were Greek background. Pytheas, although we don't have copies of his writings, we have what some later writers cited from him. He traveled definitely to England and possibly on beyond to parts of Scandinavia. He reported on the tides, which are much stronger out in the Atlantic than in the Mediterranean, and reported seeing large areas of ice, a number of distinct sightings there from that travel. Herodotus, we have much of the things that he wrote. He traveled extensively in the ancient Mediterranean region and wrote down all about it and how people elsewhere didn't do things the way that Greeks did. So he provides a relatively good picture of what was known about the world by folks in kind of late classic Greek time frame. After that, we don't have as much for written records, but meanwhile, on the other side of the globe, we had the ancestors of the Polynesians beginning to spread. As you can see somewhat on the edge of the globe here, from the mainland of Asia, there are a number of island groups. Here's the Philippines, here's Indonesia coming along here, New Guinea, and various islands there. And so spreading from island to island, people had reached the general area of Fiji, Samoa, and Tonga right in here by around 1,000 BC, same time frame as the Phoenicians are somewhat getting their start. But as we get close to 1000 AD, we had in Northern Europe the Vikings developing sturdy ships and traveling long distances on the oceans, as well as raiding all around the coasts of Europe. Some of them traveled further and eventually reached Iceland, Greenland, and finally North America. And also it was around 1000 that the Polynesians started to spread out beyond the Fiji-Samoa-Tonga area out across a vast area of the Pacific Ocean. And they developed a number of skills navigating. They had not as large ships as the Vikings, but quite well-built outrigger canoes. The outrigger provides added stability for the canoe. And they also developed very extensive skills in navigation, observing the location of stars, patterns in the waves and wind. They also knew things such as what types of birds flew way out in the middle of the ocean and what ones stuck closer to land. Different clues that they could use in order to find their way in the ocean and locate land. So within the period from roughly 1000 to 1200, Polynesians spread all the way northeast as far as Hawaii, southeast out to Easter Island, southwest down to New Zealand, and through various islands in between. As we move towards the late medieval to Renaissance time frame, we have a few examples of government-sponsored expeditions. One of the first in the early 1400s was Xing He from China. He led a series of 7 expeditions around in the Indian Ocean from China. Now, these were not really voyages of discovery. They were following well-known trading routes, but for Chinese ships to specifically visit these places was often new, and they did record information, making detailed maps and recording what the people were like and trying to spread China's political influence as well. And I wish there was a way of changing where Zoom displays this menu here, but anyway. Meanwhile, about that same time, Portugal, on the very west tip of Europe, it was basically blocked in by Spain. There wasn't much prospect of expanding in that direction. And so, it's now known in English as Prince Henry the Navigator, decided to invest heavily in navigation, training, and shipbuilding, and make Portugal a major power in trade and exploration. This led to a series of trips, and so Bartholomew Diaz in the late 1400s was the captain of the first European expedition to make it all the way to South Africa. And he was on a follow-up expedition, but died in a shipwreck on the way. And so Vasco da Gama gets the credit for completing the trip around Africa out into the Indian Ocean, replicating what the Phoenicians had done somewhat over 2,000 years earlier, but not many folks since then. And so this led to Portuguese trading stations and colonies around the Indian Ocean region and along the coast of Africa. Another fellow trained in the Portuguese schools of navigation, though originally from what's now Italy, and he went to the royal court and proposed that they could hire him to do some exploring for them. But his price was kind of high, and Portugal had plenty of other explorers. So he went and tried his sales pitch in Spain instead, and the Spanish decided that this sounded reasonably good and sent him off with 3 ships, and he made it across the Atlantic and encountered what's now part of the Bahamas on the first expedition there. This, of course, was Columbus. So we have wide exploration, discovery, what land is there, how far is it to the next land type of thing going on, and also plenty of folks who are mainly interested in, is there a spot where I can catch more fish? It was within 10 years of Columbus getting back to Spain, that fishermen from France and England and Spain were coming over along the coast of North America as well. So those are the main things going on at this stage of the process. The first ship voyage around the world was launched by Ferdinand Magellan, again like Columbus, coming out of Spain, starting in 1519. Made it around the southern coast of South America, probably the first ship to make that trip. Of course, the natives had canoes, but they weren't trying to go all the way around that far. Then had the first crossing all the way over the Atlantic, and sorry, not the Atlantic, the Pacific, and reached what's now in the Philippines. And folks at the island where he landed, Cebu, were quite glad to welcome him. This looked like it might be a useful ally against their neighbors. And so Magellan agreed to go out and attack the folks on the neighboring island, Mactan, there. Now, true, the folks there did not have European technology, but when somebody announces exactly how he's going to come and attack you, they did know enough to be able to set up an ambush. So Magellan and a number of others were killed in that, and eventually the remnants of the expedition under Sebastian Delcano completed the journey, making it back to Spain. If you go to those parts of the Philippines today, you can see on the one hand, Cebu, they still have a big monument to Magellan. There's a little shrine. They've still got a little statue representing infant Jesus that Magellan gave them. If you go over the bridge there to Mactan, you can see a nice monument to the fellow who killed Magellan, the chief there. Now, the folks on the islands aren't fighting each other these days, but it's kind of funny seeing the contrast in the monuments One of the first expeditions to have a bit more of a science focus was the series led by Captain James Cook from England. He had quite a gift for surveying and map making. This was shown quite vividly when he was sent to map Newfoundland, an island off the coast of Canada. His map was in fact so good that it was still in use up to the early 1900s. So given how well he did there, he was appointed to lead a series of 3 expeditions to explore the Pacific. Of course, part of the point of this is to claim land for Britain, and also to document what was there. So there were scientists and artists on board documenting the things found in the expedition. Now, still, this is focusing more on looking for the land, not as much of a scientific focus on the ocean itself. But the maps certainly include the ocean. We're getting a little bit more scientific on our oceanography at this point. One other very important thing about Cook was that he paid attention to health issues. In particular, scurvy was a major problem of ocean expeditions, and Cook found out that by providing some additional things for the diet, he could prevent scurvy. This was rather vividly demonstrated when an accompanying ship on one of the expeditions, and it split up to do some separate exploring for a little bit. And the captain of that ship wasn't so keen on Cook's newfangled ideas about nutrition and did not continue to provide it. And all his crew got scurvy, and Cook's men were fine. Scurvy, we now know, is a deficiency of vitamin C, and vitamin C mainly comes from fresh fruits and vegetables, which is a little challenging to have on board. But if you specifically plan, there are foods, and Cook did a good job with that sort of thing. Here are maps showing the routes for his 3 expeditions in the Pacific. It was the first to go south of the Antarctic Circle. It did not actually see Antarctica itself, but record farthest south lasted for about 50 years or so. Explored a number of islands, some of them actually discovering. A lot of them other people had gotten there, but Europeans did not know about them. Additional areas covered include along the east coast of Australia and the west coast of North America, at least what could be seen despite the fog. Cook's fame as an explorer eventually led to Ben Franklin introducing a resolution that the American Revolutionary Forces should not treat Cook as an enemy if they happened across him. Unfortunately for Cook, 1, this resolution came a little late, and 2, Hawaii was not to be a part of the United States for roughly another century. On the 3rd expedition, Cook's ship was the first European ship to reach Hawaii, and they had reasonably good interaction with the locals there. Circling around, they came back to Hawaii, and a dispute came up. Now, for the 1700s, Cook believed in treating natives relatively decently, but one of his standard solutions for a dispute with the natives was to invite the local chief on board the ship and then not let him off until things were resolved again. So Cook was attempting to do this in Hawaii, and the natives got suspicious. A fight broke out, and Cook was killed. This also inspired a number of further expeditions. United States and France, as well as England, got into the scientific exploring expedition effort. One of these later exploration trips was the Beagle, again British, 1830s, traveled across the Atlantic, around South America, across Pacific, and eventually all the way back around to England once more. Of course, this trip is particularly famous for one of the sort of passengers on the ship, Charles Darwin. Officially, his job was to be somebody not so low class that the captain couldn't chat with him, but largely he was there for observing things scientifically. So he made quite a lot of geological and biological observations, collected a lot of specimens that were sent back to Europe. Later he became an expert on barnacles. Of course, those are ocean creatures as well. Now, picture here is not what he looked like in 1831, the Beagle, much later in life. Darwin's somewhat interesting meteorology. He liked weather in England. He didn't like the way tropical weather was nice all the time. Thought that was boring. Well, anyway, we will encounter some of Darwin's geological ideas later on here. The first expedition to really focus on the ocean itself, rather than crossing the ocean to land, was the Challenger expedition, again a British expedition, in the late 1800s. This is a picture of the ship and the captain there. Here's the map. You see there's a good deal more wandering around out in the middle of the ocean rather than heading straight across than what we've seen before. The Challenger also was equipped with equipment to put scoops and other measuring equipment down deep into the ocean. So it was one of the first times that the very deep ocean floor was sampled. Among other things, they disproved the idea that down in the cold, dark pressure there that nothing lived. The United States got into the act. The first large ship specifically designed for an ocean research vessel was the U.S.S. Albatross in 1882. It was in service for nearly 40 years. A smaller kind of trial run ship was built a couple years earlier by the U.S. as well. One important part of the job was documenting where fish could be found and other ocean life for commercial purposes, but also it took extensive samples of the ocean floor, documenting things. There's still collections in the Smithsonian that nobody's had time to look at from the Albatross's sampling expeditions. And Zara Luther Taylor, pictured here, was the first captain of it. He also was involved in designing the ships for research. I do not know if he was involved in designing the side whiskers as well. Another notable discovery voyage in the late 1800s was the Fram, which crossed the Arctic Ocean for the first time. Many folks were surprised when the crew made it back afterwards, but the plan was to sail north as far as we could, get stuck in the ice, and then drift in the ice across the ocean, and it proved successful, although definitely the extensive reinforcement of the ship was necessary to do that. An ordinary ship would have gotten crushed by the ice. What about ocean research today? Some of the changes. These historical expeditions we've looked at, if they were formal expeditions, they tend to be one country putting this out as, look how great we are, all the things we can do here. Today, major expeditions tend to be international, partly due to the expense, share that around. Locations, what's that boat doing out off of our coast? Well, if you've got the people there involved, then you are going to have better relationships there. Also, research, often large-scale problems, people all around the world are interested. And so cooperation and involving many different people is an important part of modern oceanographic research. Now, sure, there's still more that could be done to make sure that anybody who's interested could, but it is something that has made a lot of progress. A lot of new technology. Submersibles, remotely operated vehicles, is basically a robot submarine. Well, submarine in the ocean context, you can have remotely operated vehicles as space robots or wherever, but for the ocean, that would be robotic submarines. Ability to get things down to the deepest parts of the ocean. Although it's challenging, it is possible. Computers, very, very important. Lots and lots of data, so much so that one person alone can't figure things out, but with computers, we can handle much more complicated calculations, very large data sets, putting these together to have better understanding of the ocean. A lot of remote sensing as well, whether it's a device carried by an airplane or satellite. These give us big pictures of the ocean as a whole, so we can see what's happening with weather out where there aren't any ships. Many other ways this is telling us about the ocean, and meteorology for that matter as well, being very important. Here are some examples. The pictured satellite has a particular role of measuring the exact distance from the satellite down to the Earth's surface and back. In this case would be the ocean surface. Okay, and that measures all the little tiny bumps and dips in the ocean surface. Oh, of course, yeah, there are waves out there. But in addition, actually, that tells us a bit about the bottom, as we'll see in a little bit. The submersible pictured on the left here is probably the most famous research submersible, Alvin, named for Albert Vine. It's been going for several decades. It doesn't go to the very deepest parts of the ocean, but it can go relatively deep down and has done a lot of major ocean exploration. It's pretty tight in there, not a whole lot of room. That's true of submarines in general. Alvin has space for the pilot plus 2 researchers. So the waiting list to be able to take your research trip on Alvin is quite long. One person who realized that was Cindy Van Dover. She's done quite a lot of research on the deep ocean. And she, thinking about this, got a bright idea. Every time Alvin goes down, there's got to be a pilot. So she took the training and got certified as a pilot for the Alvin. So she could be driving the submarine and got to be down in the ocean and looking at things while it was officially somebody else's research project, as well as when she was able to be the official researcher there. So that got her a whole lot more time down deep in the ocean observing things. We also have some major research ships. Particularly notable are the series, the Glomar Challenger was the first one, and then we've had a couple of replacement updated versions since then. That big tower in the middle of the ship holds a drilling rig that is able to reach all the way down to the bottom of the ocean, and then from there drill deep into the ocean floor and bring up the rock and mud and all that it's drilled through so that scientists can study it. So since 1970, these ships have been going out regularly, roughly a month to a few months at a time, across an ocean, going to various spots that scientists have identified as being an interesting spot to drill, documenting the information. You have lots of scientists on board the ship who are interested in a particular area, getting the chance to travel with it, and then the cores are brought back and stored, and other researchers can study them. You also have the publications. There are shelves and shelves of massive books telling all about the things found with each of the now many thousands of drill holes made by these expeditions. A couple of things to keep in mind as you're looking at things for oceanography or other contexts as well. One is paying attention to the scale on graphs. This is an example. We have a curve here representing the amount of zooplankton, mostly small animals drifting around in the ocean, relative to the water depth. And as you can see, it's highest up here at the top of the ocean and keeps on dropping off deeper you go. But if you look closely at the numbers, you see 0.1, 1, 10, 10 squared, it's 100,000. These numbers are going down very quickly. This is a logarithmic scale rather than a linear scale. So in a linear scale, it would look like this: 1,000, 750, 500, 250. And from this one, it's easy to see that vast majority of plankton is living right near the surface, and it drops off very quickly. By the time you're just 1 kilometer down, there's a whole lot less. And by the time you're about 2 kilometers down, there's hardly any, and well, it's already hardly any. It stays hardly any down here. So on this graph, it's obvious that it drops off real fast. Not so obvious what happens down here. Go back to this graph. Here, how fast it's dropping off is not so obvious, but this makes it easier to see that it continues to get less and less the deeper and deeper we get. So the different versions of the graph are helping you see different things, but it's important to pay attention to make sure you're reading it correctly and understanding it. One of the most common places where we'll be seeing those will be with diagrams relating to depth of things in the ocean, such as the one here. In the diagram as shown here, 50, 100 kilometers, water depth, 100, 200, 300 meters. Kilometer is 1,000 meters. So this picture has actually been squunched quite a bit horizontally relative to the vertical scale. Why do that? Well, the picture down here shows, oops, picture here shows what it would look like in the actual proportions. And you can't really see a whole lot there. So by stretching it vertically, it's much easier to see, okay, here's where you've got stuff washing off of land. That's what the modern intrusion sediment means. Going out, older stuff, and then sloping some, but relatively flat up here, dropping off much more steeply there. Now, much more steeply doesn't, well, it's in the dark, but if you could be down there and had enough light to see, it would look like a slope and not nearly as steep as it looks here. But in the diagram there, it makes it easier to see. You just have to keep in mind we've got different proportions in the different sides. Again, as we talked about earlier, science, great approach, tells us all sorts of useful and interesting things, but there's lots that it doesn't tell us. We have examples. Bible, Psalm 104, talks about the sea, creatures teeming in there, ships, Leviathan, and the like. Earth trembling, mountains smoking. We'll look a bit at those, how they relate to the oceans as well. Job also talks about the sea, the deep there. Now, part of it's just general appreciation of creation, neat things, all sorts of stuff to learn about. There's a theological message that we might miss in there. The sea impressed folks, at least in the ancient Near East, as being chaotic, unpredictable, and so it was personified as a chaos monster rivaling the gods. And Psalm 104, Job 20 is saying, no, they're just stuff God made. What others thought was a rival to gods is just a little part of all the things God made. Okay. So that has an introduction to the history of oceanography. We'll stop this and then take up looking at the form of the ocean.